All right, so we just finished up differentiating inverse functions in general, and now we're going to talk specifically about inverse trig functions. All right, so let me just run through quickly a proof here. So imagine I wanted to find the derivative with respect to x of the inverse of the sine function. So we call that arcsine or inverse sine. Right, I want to find the derivative of arcsine. All right, well, if my function is the arcsine of x, then if I take the sine on both sides, I will get sine of y is equal to x, because sine and arcsine undo each other. Now I'm going to take the derivative with respect to x on both sides of this equation. Derivative of sine is cosine, but because that's a y and I'm taking the derivative with respect to x, I have to multiply by dy dx. Derivative of x is 1. Divide both sides by cosine y, and I get dy dx is 1 over cosine of y. Now, I don't want my derivative of a function of x to be in terms of y, so we're going to do a little bit of manipulation here. All right, so I'm sure you're familiar with the Pythagorean identity, sine y plus cosine squared y. I'm sorry, sine squared y plus cosine squared y is equal to 1. Subtract sine squared on both sides, and then take the square root on both sides. And I'm going to end up with the square root of 1 minus sine squared. Now take this and replace the cosine y down here with that. So I have 1 square root of 1 minus sine squared of y. All right. Now recall one last thing here. Sine of y is actually equal to x. So this becomes 1 over the square root of 1 minus x squared. So what I've just established there is that the derivative with respect to x of the inverse sine of x is 1 over square root of 1 minus x squared. Put that into chain rule form. If instead of an inverse sine of x, if it's inverse sine of some function of xu, you're going to end up with 1 over the square root of 1 minus u squared, and then by the chain rule, multiply by the derivative of u with respect to x. So if you come back over here, you'll see that's exactly what you see right here. Now, I'm not going to go through the proof of the rest of these, but you can see them here. Derivative of the inverse tangent, 1 over 1 plus u squared du dx. Derivative of arcsecant, 1 over the absolute value of u, square root of u squared minus 1 du dx. And then when you change to the cofunctions, so you go from arcsine to arccosine, it's just the opposite. When you go from arctangent to arccotangent, it's just the opposite. And same thing with arcsecant. For our purposes in AP Calculus, generally, the only ones that you get tested on are generally those three. You should be able to refer back to your notes to find the rest of them, but these three you really should just know. And realistically, you just need to know these two, and then the arc cosine is just the opposite of that. So we'll run through a few examples here. Derivative of the inverse sine of x squared. So the derivative of the inverse sine of x squared by the above formula is 1 over 1 minus u squared times the derivative of u with respect to x. So kind of in a simpler form, 2x over 1 minus x to the fourth under the square root. So there you go. How about the derivative of inverse cotangent? Well, we'll just follow the formula right here. So that is going to be negative 1 over 1 plus u squared times du dx. So that looks like negative 1 over 2 radical x, 1 plus x. So you're just following the formulas here. Number 3, derivative of arctangent. So by the arctangent rule up above, I've got 1 over 1 plus u, which in this case is cosine. So 1 plus cosine squared, multiplied by the derivative of the cosine, which is negative sine of x. So this is negative sine over 1 plus cosine squared. Again, really just following the formulas. All right, and then the last one here is if f is equal to arctangent of x, then what is the limit as x approaches the square root of 3 of f of x minus f of square root of 3 over x minus the square root of 3? So what you are supposed to get out of this is that this thing right here is the definition of the derivative of f at the square root of 3. So in other words, this is the derivative of the f function, which is inverse tangent of x, evaluated at the square root of 3. So let's start with the derivative of inverse tangent. F prime of x, which would be the derivative of the inverse tangent, we know, and it's just inverse tangent of x. So it's 1 over 1 plus x squared. That's this rule right here, where x is, or u is just x. Okay, and now I need to evaluate that at the square root of 3. So what is f prime at the square root of 3? It's 1 over 1 plus the square root of 3 squared, which is 1 over 1 plus 3, which is 1/4. So that is B.